Hi, welcome to the new session of Circuits and Networks. In today's class, you are going to see MATLAB models under single phase AC circuits, and this particular session we are going to treat as class 2. So, what we have seen from our basics of RLC circuit when they are connected to AC, and input is given as V is equal to Vm sin omega t in all these passive elements, we have observed that the current in resistor is in phase, whereas in current through inductor lags voltage by 90 degrees, whereas in capacitor current leads voltage by 90 degrees. Also, we have seen the graphs of phasors, in fact phase diagrams, that is voltage in phase with current or current in phase with voltage in the case of resistor, and in the case of inductor the current lags voltage, whereas in capacitor the current leads voltage. So this particular thing we have already discussed in our past classes, especially when we were dealing with single phase AC circuits, theoretical calculations and problems based upon single phase AC circuits, all we have done in our past classes. Then in our previous class under MATLAB, we have seen also the circuit model, that is the simulation model. In today's session, we are going to see this voltage and current which are lagging or leading when the resistor is combined with inductor and when the resistor is combined with capacitor. So when RL circuit is there, this is how the source voltage is driving the passive elements, and since it's RL circuit, the inductor plays an important part over here, and that is why the current lags voltage. Whereas in capacitor, when you consider RC circuit, the current leads voltage. So this is what we have seen in our theoretical classes, and also we have solved many numerical based upon these concepts. So voltage and current relations, that is in lagging and leading, this can be purely observed with the help of MATLAB model. So here I'm showing you the directly the MATLAB model where you have input source voltage, you have resistor, you have inductor, and this is a MATLAB circuit connected over here where you can see the input voltage is 100 volts. Okay, and RL circuit is connected and voltage is measured across RL circuit. So that voltmeter is going to give you the waveform of voltage across RL. The resistor value is 2.5 ohms. The inductor value is 10 millihenries. You can have your own values, so you can check out with different values of resistors and inductors, and you can observe the waveforms. Similarly, current through RL circuit can be also obtained, and that waveform is also shown over here. This is the scope which is showing source voltage, uh, output, and the output across the RL circuit, and output current through the circuit. So all these three parameters you can easily observe in this particular scope, whereas I have used mux where I have combined the voltage and current waveform, and simultaneously these two waveforms can be displayed on this particular scope, and that is the output you can see over here, which is voltage and current, where current lags voltage. Fine. Similarly, with the case of RC circuit, where you can see 100 volts is driving RC network. The resistance value I have selected as 0.75 ohms and capacitor value as 500 microfarads. So for this also, how the outputs are obtained, that is shown under this scope, and the combined value of voltage and current waveforms through the passive element is shown in this another scope, and that output is shown over here. So how this is done, so that you can easily understood by dealing with a MATLAB model. So for this, I'm going to select a MATLAB model, which is over here. Yeah. So this is a MATLAB model I'm showing over here. So for easy assistance, you can go with the simulation library, where you can use a commonly used blocks. There you can find a mux over here. So I'm adding to block over here. So that already existing block is there. For that, you can see a mux is added over here. Okay, so this Marks you can take it outside. In fact, I'm going to go with the new model where I'm going to uh, place the library parameters mux over a new model like this. Okay, so a new model which is going to show you this mux is placed over here, and I'm going to use all the other parameters also. I need a scope, so I'll check whether I have a scopes over here. Yeah, I have a scope over here, so I'll add to the model, right? Sources, I don't think as of now I require any sources from the Simulink model. So directly I'm going to the Simscape model. In this, I have so many options. So I'll go with the foundation library where you have electricals. No, I don't think it is going to give me a good result. Let me go with the electricals. Yeah, in electricals, I have a specialized power systems where I can go with the fundamental blocks of measurements. So I require current measurement. So I'll go to the current measurement parameter and voltage parameter. I have added to the block. Then I'll go with the elements. Elements we have RLC. So I'll take RLC block. RLC block is also taken. Okay. Then what is the requirement? I require the electrical sources, right? So electrical source we have single phase AC circuit. So I'll take this AC and add to the model. Okay. So these things are added. Yeah, fine. Also, this power GUI is required. Fine. So I have taken this new model. Okay. So continuous I'm keeping over here. Mux is there. Source is over here. Resistance is over here. Voltage, current, scope. Fine. So let me elaborate all these blocks. Okay. And then we have to connect this as a load. So I'm formatting into the clockwise. Fine. And this I need to connect over here, so I'm connecting over this, and current has to be measured, right? So I'm changing the current position also in this downward direction such that this is connected to the positive terminal and negative terminal is connected to the negative of the source. Okay, now voltage is there. Voltage measurement is across the parameters like this, and scope we require two scopes. So one scope with number of input ports as 3 as I have shown in the diagram, and view I'll take the layout to be 3. So you can see I got here three three different parameters under one scope. Okay, I close this. So the scope is also elaborated for your convenience, and the scope is I'm placing over here. I need to require the voltage across source also. So I'll place one more voltage over this particular source, and that connection I'm going to the first parameter of the scope, second voltage across the passive elements, and third across the third across not across through the elements current measurement. And I have also taken the help of mux over here, and I'm one connection I'm going to give to the voltmeter, one connection I'm going to give to the ammeter, and the connection output is going to be given to the mux. Fine. Now the input source voltage, let me take the value as 100, and frequency I'll select as 50. So this is done. Then the value of RL circuit we are dealing with. So RL we are dealing with the values, and what was the value of inductor elements? 2.5 ohms and 10 millihenries. Fine. So I'll select here RL 2.5 ohms and what was the value? 10 millihenries. Okay, no problem. So here I'll write as 10 millihenries. So it is applied. So RL is taken, and this is taken, and you can simulate the block. Let me take the value of stop time as 0.04 and let me run this. So it is running, you can see over here. So I think the simulation is done. Let me check. Yeah. So you can see this is a source voltage 100 volts. So sine wave of 100 volts. Then the same voltage is applied across the RLC parameters. So this is also 100. Whereas current, you can see current is decreased. Current is not only decreased, but it has taken the shape of waveform, which is not starting from 0, which is starting at minus 20 roughly. Okay. So this is how you cross check the result. Okay. So this is done here. Let me check here the combined value. Yeah, you can see this is the combined value over here. So in my PPT, you can see I have a graph which is having the dimensions of grid arrangement, where the waveform of voltage and current, they are visible on the white screen of the grid connection. And in the MATLAB model, you have this. So how to change this? It's a simple thing. You have to go with the style configurations. Okay. So in the style configuration, you can check into white like this. Just apply and see what is the thing. Yeah, you can see the background is changed. Here also you can take white and apply. You can like this, and um, the waveform has to be obtained in this form. So I'll take the help of this voltage measurement. I'll take with the line. Yes, line is there. I'll take with the width of the line as 1, and let me change it to the color of red. So that is done. So that red is fine over here. And again, go with the current measurement, and it is dark blue. So let me take as dark blue. Let me apply it as dark blue and with width of 1. So this is how the output looks like. So this is the voltage waveform, and this is the current waveform. The current is lagging the voltage. I hope you understood how we got this. So this is about the RL circuit. If at all you take RC circuit, RC circuit, and just change the values as 0.75 ohms. Okay, and what is the value we have taken here for capacitor? Capacitor 500 microfarads. So 500 microfarads is selected. So you go to this, and by clicking to RC as 500 microfarads, 500 microfarads, you can apply. Okay, and again you can cross check the result. So if at all you look into this, here you can see the source voltage, the load voltage, and the current. In the previous RL model, we have seen that the current was starting from minus 20. Now here the current is starting from positive 10. Okay. More specifically, if at all you look into the combined output, here you can see the current is already started, and after that the voltage is started from 0. So here current leads the voltage. So this is how you have to check under MATLAB model. So you can check with the different models of RL, RLC, or LC, and the combinations of this you can check it with different values, and with these different values you can check out the waveforms. Also, if at all you want to place this parameter in parallel, for suppose you have this RC circuit, I'm taking another value of RC and I'm connecting to the source like this. Okay, so again you need to cross check. For that you can increase your scope like this, and just add one scope to the source, and one scope for voltage you need to again place across the branch which you have taken with the new model. So that scope I'm arranging it to this, and another I'm arranging it to this. Okay, and that you can place over here. So if at all individually you want, so you can individually also take the values. For example, I'm going to take first R, and I'm going to apply like this, and then I'm going to take C like this. Okay, and I'll remove this connection. I can elaborate this connection like this. I can place over C over here like this, and I can connect the parameter to this. like this and connecting this to ground. Okay, and if at all I want to know the voltage across resistor, that is kept like this. Okay, also I want to know voltage across capacitor, that is can also be done like this. So I'm connecting separate voltages connections for R and C separately, and I want to check the result. Okay, so let me run this. Now it is easy for us to understand what exactly is happening with resistance and capacitance. Okay, so you can see here the source is this waveform. Okay, then what we are connected? We are connected the voltage across resistor. Because of RC in series, you can see the voltage variation, how it is changing. Okay, the voltage value is changed from 100 to 10, 10 to 10 peak value, whereas a capacitor is charged to the fully value of the supplied voltage. So this is how you need to cross check the conditions. So for further information about single phase circuits or three phase circuits, you please stay connected to our channel and see our MATLAB models in different ways of connecting the passive elements to the sources, and then you can work it on your future projects, that is small projects or major projects what you're going to face in your electronics or electrical subjects in your future. So this is a kind of a revision, or you can say that it's a free hand on MATLAB how to learn from the basics. So I hope you like today's session, especially with the RLC parameters connected to the single phase AC source. So voltage and current waveforms based upon RL and RC, they get changed in this fashion. And please stay connected to this channel for further information. Please share among your friends about this channel and subscribe to the bell icon for the future notifications. Thank you.